In this video, geometry students will be studying or really reviewing ratios and proportions. Now, I say reviewing because this is information you should have had in the past years ago. In fact, I know that I taught some of you in the 8th grade, and we've already talked about ratios and proportions. I'm sure most of you have heard about this before. This is very important information because we will be using ratios and proportions throughout the entire chapter. So please take really good notes. Your heading today, by the way, the material will be very simple, but please make sure you take notes. Please make sure you pay attention, and please understand you're going to use this for the rest of the chapter. Ratios and proportions is your heading. Please copy that in your notes today, and the lesson number is 8.1. Be sure and include today's date so that your notes are organized, okay? Please copy this down. Ratios and proportions, lesson 8.1, and be sure and include today's date. Alright, let's continue on now. Simply put, and please copy this down, you're responsible for this definition. A ratio is a comparison of two numbers. You're responsible for this, so please make note of that. Simply put, a ratio is a comparison of two numbers. So, you understand we can write a ratio like this. We can say 2 to 5. That's one way to write a ratio, if you want to make note of that. Another way to write a ratio is a fraction. 2 to 5, or 2/5. Here's another way to write a ratio. 2:5. Now, if you're really familiar with all of this and you don't feel like you need to take notes on this right here, that's fine. But understand, these are different ways that ratios can be written, okay? For example, if I knew for every 2 males in the geometry class there were 5 females, then I can say the ratio of males to females is 2 to 5, okay? And so that's an example of a ratio. A ratio, simply put, is a comparison of two numbers, okay? Alright, continuing on now. A proportion. What is a proportion? Well, a proportion is when you have at least 2 ratios set equal to each other. So please copy that down. You're responsible for that, okay? A proportion is when you have at least 2 ratios set equal to each other. Please copy that down. At least 2 ratios set equal to each other. Now let me give you some examples, okay? For example, I could say 1/2, that's a ratio, equals 3/6. That's a true statement, is it not? Sure it is, okay? So I have a ratio here, a ratio here. I've set them equal, so this whole thing right here is called a proportion. Got it? Okay, now notice in the definition of proportion, I say at least 2 ratios set equal to each other. So I could also say equals 5/10. This whole thing here would be a proportion, okay? 1/2 equals 3/6 equals 5/10. This whole thing would be a ratio, This whole thing would be a proportion, alright? So a proportion is when you have at least 2 ratios set equal to each other, and obviously, if they're set equal to each other, they have to be truly equal to each other. You could not say 1/2 equals 4/7 and then claim that you have a proportion. This is not a proportion because these 2 fractions are not truly equal. Okay, so understand that. Now let's talk about a couple more things that you need to know. All right, you do need to make note of this. Okay, let's use letters this time. Let's say A over B equals C over D. Now, these 2 numbers here, or in this case they're variables, are called your what? Do you guys remember? They are called the extremes, okay? So these 2 numbers, whenever you have a proportion, these 2 numbers here, or variables, are called your extremes. These 2 numbers here, or variables here, they're going to be called your means. So as you can see, a proportion is made up of means and extremes, okay? Now here's how I remember this. Alphabetical order, E comes before M, so top left would come first, and the bottom here left would come second. So when you start up here at the top, that's E comes first, extremes. And of course you circle diagonally like this. And then down here at the bottom left is second. So M is second means. And of course you circle diagonally. So these two numbers here are your extremes. And these two numbers here are your means. Okay? Now, one other thing you need to know. Don't forget you learned this also a long time ago. That whenever two fractions are equal, you can cross multiply and you'll get the same number. 2 times 2 is 4. 1 times 4 is 4. Mr. Earhart, will that always happen? Yes, as long as the two fractions are truly equal. Anytime you cross multiply, you will get out two equal statements, okay? So please don't forget that. We're going to use that a lot in this lesson today. Alright, moving on. Now, you do not need to turn in your books to page 374. However, if you did, here is what you would see. You would see this right here. Now, I am not going to make you learn these. These are what I call amazingly common sense. Okay, let me show you what I mean. And that's not what I meant to do. Alright, now take a look at these guys. Again, I would not take notes on this. I would just watch. Okay, look, I just show this to you. We call this the cross product property. Have you noticed, students, that I do make you memorize a lot of definitions, theorems, corollaries, and postulates? However, whenever I can make you skip those and not memorize them, I try to do that. So as you can see here, I am not going to make you memorize this. There's no need. You know by now that if you multiply these two together, AD, and then multiply these two together, BC, they're going to equal each other. Okay? I just showed that to you about 60 seconds ago. Alright? They call this the cross product property, but we know that from a long time ago, so I'm not going to worry about that. Also, in your book, you'll notice they have this next property, which is called the reciprocal property. But look how funny this is, guys. Look, if A over B equals C over D, then they flip the two fractions, then B over A equals D over C. Well, I mean, to that, of course, I say, duh. I mean, it's just so obvious. That's obvious. Look, 1 over 1 half equals what? 3 over 6. So let's flip this fraction. 2 over 1 equals, flip this fraction, 6 over 3. Well, of course, 2 over 1 is 2. 6 over 3 is 2. So that is all that this property is saying, is if you're given a ratio like this, you can flip both sides and they're still equal. But really, guys, we should know that, okay? That's not any type of earth-shattering property, alright? Okay, let's continue on. Now, let's go ahead and jump into some problems right away. So in your notes, you do not need to write all this down. Okay, just listen to me. You're on a trip with your family, and you're amazingly bored as you travel down the highway. Now, in my family, when the kids get bored, they start killing each other in the back seat. Anyways, you started keeping track of cars, and you're counting the cars that pass you that had one passenger, and you start counting the cars that pass you with more than one passenger. Here's the data you ended up with. Now, I do want you to copy this down. Copy this down. There were 320 cars. I guess you're really mega bored, okay? Because you did this for quite a while. But there were 320 cars that had one passenger. There were 180 cars that had more than one passenger, okay? Now, please copy that down. Please copy that down, then answer these questions. You can work ahead, or you can stay with me, but please make sure your answers are accurate. Here we go. Alright, I want to know the ratio of one passenger to more than one. Okay, no problem. What comes first? The one passengers, that's 320. 2, the cars with more than one. Well, that would be 180. Now, students, please listen. Anytime I ask you to give me a ratio, I expect you to reduce it completely. I do not have to tell you that, okay? So if you reduce this, cross a 0 off, you're left with 32 and 18. and 2 goes into both of these, so you're left with 16 to 9 is your ratio. Now, you can write it like this. You can write it with a colon, or you can write 16 over 9. I have no preference at all, okay? It's totally up to you. Alright, let's try another one, okay? Write down the ratio of 1 passengers. So how many 1 passenger cars did we have? 320. 2. The total cars, well, 320 plus 180 would be 500. Okay, let's reduce this. Cross a 0 off, and then divide by 2. You would get 16 over 25, or 16 to 25. Okay, so that would be the ratio of 1 passenger to the total cars. Is this making sense? I hope that it is. It's pretty simple stuff. Number 3, I want you to write the ratio of total cars to more than 1. So the ratio of total cars, it's 500. 2. The cars that had more than 1, 180. Now let's cross off the zeros. We're left with 50 to 18. Divide by 2 and we end up with 25 to 9. 25 to 9. Okay? Hope that makes sense. Pretty simple. We're just writing ratios, allowing them to represent certain situations. Alright, let's continue on. Use this ratio here for the next 2 questions. Are you ready? Here we go. Please take some really good notes. What are the means? Okay? Well, remember, the extreme. Remember, the 2 words are extremes and means. Alphabetical order, which one comes first? This does. So the extremes come first up here. So the means start down here. So the means would be 2 and 5. Okay? Those are the means. Now, what are the extremes? Well, the extremes are up here. So 1 and 10 are the extremes. Now, like always, students, if I'm going too fast, just have the supervising teacher pause the video, okay? Make sure you're staying on top of your notes. So that is the extremes. Now, continuing on. Lastly, this is a really short video. You're going to spend most of your time working on homework. Plus, I knew that we had to go over your test today, and so that's why it took a little bit of time also, okay? So, lastly, let's solve these 2 equations. Alright, let's start off with this one here. Let's solve for y. Remember what to do. Cross multiply. 5 times y is 5y, correct? Now cross multiply. 3 times 8 is 24. Now remember, please listen to me, students. Anytime 2 fractions are equal, you can cross multiply, and the 2 products are going to be equal always. Now divide both sides by 5, and your answer is 24 fifths. Okay, that is your answer. Or you can write it like this if you want to. 4 and 4 fifths. Or you could write 4.8. Any of these answers are acceptable. Okay? Now let's try this other one over here. Now be careful on this one, okay? First of all, let's cross multiply, okay? Now when you take b plus 3 times 4, that's really going like this. 4 times b plus 3. So both of these terms, b and 3, will get multiplied by 4. So b plus 3 times 4 is 4b plus 12. 4 times b is 4b. 4 times 3 is 12 equals. Now we cross multiply here. 2 times b is 2b. Well, students, look, we have what I call a simple linear equation. Let's solve this, okay? Bring the 4b over and make it a negative 4b. That leaves you with a 12 over here. 2 minus 4 is negative 2. And now divide both sides by negative 2, and you're going to get negative 6 for your answer. Negative 6 equals b. Okay, and by the way, students, if you want to check that real quick, let's see if you're right, okay? Let's put negative 6 in for b. And let's put negative 6 in for b, okay? And let's see what we get, alright? 2 over negative 6 plus 3 would be negative 3. that's a true statement, guys. If you reduce 4 over 6, you get 2 over 3. So this is the correct answer. Okay? Alright, now I know it's been a really short video, but guys, like I've told you before, I can be really boring and long, or I can give you time to work on homework in class. My philosophy is, I think this math is really easy. I think that you understand it. I think you need to practice it now in your homework, okay? If you have any questions, hope this video has made sense. If you have any questions, don't hesitate to call or email.